Till now we have covered linear data structures. So all the abstract data types that we went through, they had specific ordering of the elements. And now we are going to look at non-linear data structures. And first of it is going to be tree. And within tree, we are going to focus specifically on binary tree. Okay. So first of all, let's define what do we mean by tree. Okay. So here is the definition of the tree that we'll go with. Okay. So we'll say that a tree could be an empty tree, which means that there is no node inside it. Okay. So if there is nothing still, it's a valid tree. Otherwise, we will say that there could be a single node tree. So this tree will contain just particular one node. So for example, I can denote a node with a circle and contents of the node with, say, letter or a number, but in general it can contain any type of data inside. Okay. So that's my single node tree. And then I can define tree with multiple nodes. Okay. So tree Okay. So what will I require is given trees T1 and T2, what I can do is I can create a new tree by inserting a new node such that T1 is a child and T2 is also a child of this node. And when I keep the restriction that I can have at the most 2 children, I have a binary tree. When I remove this restriction and I can have any number of children, then I get a general tree. Okay? And now we are going to have this parent-child relationship between the nodes. So we will say that, let's call this new node as, let's say, T. Okay? So what is going to happen is, this small t is going to be the parent of T1 and T2, and T1, T2 are going to be the children of the small t. Okay? So that's what the tree will be for us. So once we define the tree, we can implement the tree in many different ways. The most obvious, most discussed representation is the linked representation, where each node of the tree will have a certain block of memory assigned to it, and then to represent the parent-child relationships, each node would store the address of its children, and each node would also store the address of its parents. Okay, so that's the linked representation of the tree. But remember, even though it's the most used representation, it's not necessary that it is the only representation. Just like for the list, linked list is a most obvious representation for the list, but it's not necessary that a list should be implemented only as a linked list. You can implement it in many different ways. We have seen it, and same applies to the trees. Okay. Sometime when in our course we get time, we will look at heaps, and there we'll see that we would be dealing with tree using arrays as well. Okay. Just to understand how we are now shifting from linear data structure to non-linear, think about the linked list that we had. Okay, so we had the head node, and let's think about the W linked list. So I had the previous pointer as null because this was my head node, and then I had the next pointer. It was pointing to exactly one particular node. Whereas now when I go and build a tree, I have a root node that I start with, and this root node doesn't have any parent, right? So there is no parent for my root node, But now root node has two paths. It has a left child, it has a right child. Okay. So in case of doubly linked list or singly linked list, well, there was only way forward and way back. There was nothing else. Whereas in case of binary trees, now I could go left, I could go right. Okay, and from here again I can go left, I can go right, or from here I can go left, and so. Okay. So that's what creates the non-linearity. Now there is no one particular order of my elements. So let's ask the question, oh, well, what this tree can represent? Well, it can represent a set of values. The values would be stored inside the nodes, and then these are not just values, this is not just a set, but there is a hierarchical order between those values. Okay? And this hierarchy comes useful in many places. Okay? So we'll look at the applications, but representing our data as a tree, and specifically binary tree, gives us this hierarchy, this parent-child relationship, and that's the new feature as compared to the linked list which we are going to use, and that's what is going to have different ways to deal with data when we talk about binary tree.